Dear students, welcome to mathematics online classes. In the last class we did up to problem number 18. Now problem number 19 onwards. Problem number 19 is integration of 6x plus 3 by x square plus 4 with respect to x from 0 to 2. This is problem number 19 given. Now integrating it. See here, we will write it as sum of two functions. First 6x by x square plus 4 plus 3 by x square plus 4, sum of two functions I am writing into dx. Next, better instead of that what we do, we take 3 common here, that simplifies the problem further. See, instead of this let us take 3 common. From these two 3 is common. If you take out 3, this become 2x plus 1 divided by x square plus 4 into dx. From 0 to 2 it will be as it is. Okay. Now I will write it as sum of two functions. First one is 2x by x square plus 4 plus of second one is 1 by x square plus 4. Integrating the function with respect to x. This is, now let us write it as sum of two integrals. First one is 3 times integral of 2x by x square plus 4 into dx from 0 to 2. 3 will get multiplied to the second integral also. This becomes 3 times integral of 1 by x square plus 4 can be written as 2 square into dx from 0 to 2. Now, is it very easy to integrate or not? Yes, it is very easy to integrate. In the first integral what we do? We substitute t is equal to x square plus 1. Now, in first integral let us substitute t is equal to x square plus 4. This become dt by dx is equal to 2x plus 0. That is, I am writing dt is equal to 2x into dx. Now what happens here? What about the upper limit and lower limit? When x is equal to 0, lower limit, then t is equal to 0 square plus 4 means it is 4. Next, upper limit, when x is equal to 2, what happens to the upper limit for the variable t? This is x is equal to 2, 2 square plus 4. 2 square plus 4 means 4 plus 4, it is 8. Second integral, how will you integrate second integral? Second integral is direct. Here in second we will use the formula integration of 1 by x square plus a square with respect to x. We know this as 1 by a into tan inverse of x by a plus c. Okay. Now 3 times. First one, it is integral of 2x into dx is dt. 1 divided by x square plus 4 is t. Okay. 1 by t into dt. Lower limit, when x was 0 it is 4, upper limit when x was 2 it is 8. This is about first integral. Plus 3 times. What about the second integral? Second integral we will write, it is in the standard form. Directly we will write, it is 1 by a means here 2. 1 by 2 into tan inverse of x by a means it is x by 2. Okay. 3 into 1 by 2 is constant multiple, let it be outside. From 0 to 2, upper limits and lower limits. Next, it is 3 into, what is integration of 1 by t? We know it as log t. Log t from 4 to 8 plus 3 by 2 into, we will substitute the upper limit, tan inverse of 2 by 2 minus tan inverse of 0 by 2, it is 0. We have 3 into log 8 minus log 4 plus 3 by 2 times tan inverse of 1 minus tan inverse of 0 is what? Tan inverse of 0 is 0. We have 3 times, it is in the form log m minus log n. Log m minus log n formula, log m by n means log 8 by 4 plus 3 by 2 into, here tan inverse of 1, tan 45 degree is 1, you know. So tan inverse of 1 is pi by 4. 4 ones are 4 2s. This is 3 times log 2 plus 3 pi by 2 into 4, 8. You can write it as log of 2 to the power of 3 also, that become log E8. This is about problem number 19. Now moving to the next 20th problem. Problem number 20 is integration of x into e raised to x plus sin pi x by 4 plus sin pi x by 4 into dx from 0 to 1, integrating from 0 to 1. Okay, here this one we will take it as sum of two integrals first. First integral is integration of x into e raised to x into dx from 0 to 1 plus of. Second integral is integration of sin of pi x by 4 into dx from 0 to 1. How will you integrate this first one? We will integrate first one using the integration by parts. And what about the second one? Second one is the direct integration. Integration by parts according to the Evaluator rule. According to the rule Evaluator, here we say x is algebraic function, e raised to x is exponential function. Algebraic will come first, followed by exponential. So product of two functions, integrating it. First function as it is, integration of second function, integration of e raised to x with respect to x minus of big integral and differentiation of first function with respect to x into integration of second function with respect to x. Here you have to be careful, because upper limit and lower limits you see it is 0 to 1. 0 to 1 you write like this, it is fine. 0 to 1 it is fine, like this you can write. And here it is 0 to 1 into dx over next plus of. How will you integrate the second integration of sine? It is a direct integration of sine. It is in the form of f of ax plus b. Integration of sine is minus cos pi x by 4 divided by what? Divided by coefficient of x. X coefficient is pi by 4. From 0 to 1, integration completed there. This is x into e raised to x from 0 to 1 minus of. See here, you should not write 0 to 1 here, because this is a function, this should be integrated with this big integral. Hence, don't put here upper limit and lower limits and integrate it. No, you should not do like that. Integrating from 0 to 1, differentiation of x with respect to x is 1, leave it. Integration of e raised to x is e raised to x into dx. Next, plus of, here substituting the upper limit and lower limit, minus cos of pi into 1 by 4, cos pi by 4 by pi by 4, plus into minus, sorry, here minus will be there, here one more minus becomes plus, into cos of pi by 4 into 0, cos 0 divided by pi by 4. Yes, we have, here I can put upper limit and lower limits, 1 into e raised to 1 minus of 0 into e raised to 0, means it is 0. Next, minus of e raised to x integration, it is e raised to x from 0 to 1 plus of, what happens here, 1 by pi by 4 is common, take it outside, minus of cos pi by 4, cos 45 degree value is 1 by root 2 and plus cos 0 value is 1. Okay, we have e minus of, substituting the upper limit, e raised to 1 minus of e raised to 0, we have to be careful, plus of, this can be written as 4 by 5 and it is 1 minus of 1 by root 2, 1 minus of 1 by root 2 it is. Okay, we have e, this minus will get multiplied with these two, minus into plus, minus e, minus plus, e raised to 0 is 1, then we have plus of 4 by pi into If you want, you can cross multiply, that is root 2 minus 1 by root 2. Get cancels. It is 1 plus 4 by pi into root 2 minus 1 by root 2. We will leave it here only. This is about problem number 20. Now, problem number 21. Problem number 21 is choose the correct answer. Choose the correct answer. 21 is given as integration of 1 by 1 plus x square with respect to x from 1 to root 3 is equals option A pi by 3, option B 2 pi by 3, option C pi by 6, option D pi by 12. This is about 21. Now problem number 22. Integration of 1 by 4 plus 9x square into dx equals it is integrating from 0 to 2 by 3. What about option A? Option A is pi by 6, option B it is pi by 12, option C it is pi by 24, option D is pi by 4. Okay. Integration of this is very easy. You can say 1 by 1 plus x square. It is in the standard form. Yes. What is the integration of 1 by 1 plus x square? It is tan inverse of x. Tan inverse of x from 1 to root 3. Yes. Tan inverse of root 3 minus tan inverse of 1. Tan inverse of root 3 is 60 degree, pi by 3 minus tan inverse of 1 is 45 degree. That is pi by 4. 60 degree minus 45 degree is 15 degree. 15. Where is 15? Pi by 12 is 15. How? We can simplify here. This is 4 pi minus 3 pi by 3 into 4 means 12. We have pi by 12. Next, coming to this. Here, from the denominator, what you do? X square coefficient is 9. Don't have x square coefficient as 9. Take that 9 outside. That become 1 by 9 into integral of 1 divided by 4 by 9 plus x square integrating from 0 to 2 by 3 into dx. Okay, this is 1 by 9 into integral of 1 divided by this 4 by 9 is there, no? You write it as 2 by 3 whole square plus x square into dx from 0 to 2 by 3. 1 by 9 it is outside. Now it is in which form? It is in the standard form 1 divided by x square plus a square. Its integral is 1 by a into tan inverse of x by a. 1 by a, 1 by 2 by 3 into tan inverse of x by a means x by 2 by 3 integrating from 0 to 2 by 3. Okay, this is 1 by 9 into 3 by 2, 1 by 9 into 3 by 2 into substituting, let me write one more step. This is tan inverse of this become 3x by 2, 3x by 2 from 0 to 2 by 3. Here 3 1s are 3 3s are, this is 1 by 6 into substituting the upper limit, tan inverse of 3 by 2 into x is 2 by 3 minus tan inverse of 3 by 2 into 0, that is 0. 1 by 6 into, here you see 3 3 get cancelled, 2 2 get cancelled, that is already 0. Tan inverse of 1 means pi by 4, 45 degree. 1 by 6 into pi by 4, it is pi by 24. Yes, with this exercise 7.9 completed. We will move on to the next heading. Next is evaluation of definite integrals by substitution. Evaluation of definite integrals. Evaluation of definite integrals by substitution. Under this heading, directly we will take the problems. No need of explaining any kind of theory here. In that, example 28 is given to us. Example 28, it is given as integral of 5 into x raised to 4 into square root of x raised to 5 plus 1, x raised to 5 plus 1 into dx from minus 1 to plus 1. From minus 1 to plus 1. Okay, just look into the problem, how we can solve by method of substitution. They will not mention you solve by this method, solve by that method. Looking into the problem, you should come to know which method to use here. Okay, if I substitute t is equal to x raised to 5 plus 1, will it give me x raised to 4 or 5 into x raised to 4 or not? Yes. You substitute. Let us substitute t is equal to x raised to 5 plus 1. This is dt by dx is equal to differentiating the function with respect to x. We have here 5 into x raised to 4. That is nothing but dt is equal to 5 into x raised to 4 into dx. Okay. Now, as substitution is going on, we need to change the upper limit and lower limit for the new variable. When x is equal to minus 1, then t is equal to minus 1 to the power of 5 plus 1. Minus 1 to the power of 5 is minus 1, this is plus 1, we have 0. Next, when x is equal to plus 1, when x is equal to plus 1, t is equal to plus 1 raised to 5 plus 1. 1 plus 1 is 2. Okay. Now, our integral will become integration of square root of x raised to 5 plus 1 is t. Okay, you write it as t. 5 into x raised to 4 into dx is nothing but dt. Write dt, and in place of minus 1 it is 0, in place of plus 1 it is 2. Integration of root t with respect to t from 0 to 2 it is. What is integration of root t? 0 to 2, root t we will take it as t to the power of 1 by 2 into dt. Now we can integrate, it is in the standard form, that is x raised to n form. Integration of t raised to 1 by 2 with respect to t is t raised to 1 by 2 plus 1 by 1 by 2 plus 1 from 0 to 2. Let me simplify this. T to the power of 1 by 2 plus 1 is 3 by 2 by 3 by 2 from 0 to 2. This is 2 by 3 into t to the power of 3 by 2 from 0 to 2. Okay. Now we will substitute the upper limit and lower limit. 2 by 3 into 2 to the power of 3 by 2 minus of 2 by 3 into 0 to the power of something is 0. This is 2 by 3 into 2 to the power of 3 by 2. Okay, this 2 to the power of 3 by 2 can be written as 3 by 2 can be written as 1 plus 1 by 2. 1 plus 1 by 2. You see? Yes. Means here 2 by 3 into this one I will write it as 2 into means 2 to the power of 1 into 2 to the power of 1 by 2. Yes. If you multiply this become 2 to the power of 3 by 2 only. Yes. 2 into 2 4. 2 raised to 1 by 2 is root 2. 4 into root 2 by 3 is the answer here. Yes. Next, move on to the example 29. Example 29 is very simple, that is example 29. Evaluate integration of tan inverse of x by 1 plus x square into dx from 0 to 1. How will you integrate it? We can go with integration by substitution, that is, you substitute t is equal to tan inverse of x, we will get 1 by 1 plus x square into dx. Change the upper limit and lower limit, you will get the answer. I am leaving it to you. Now let me take the exercise 7.10. Exercise 7.10. Exercise 7.10, evaluate the integrals using substitution. Evaluate the integrals. Evaluate the integrals. In that, first one, integration of x by x square plus 1, x by x square plus 1 into dx from 0 to 1. From 0 to 1. How will you solve? Yes, just you substitute t is equal to x square plus 1, you will get one differentiation in that. Means if you differentiate, you will get x in that. Then you change the upper limit and lower limits also for the new variable, you solve it. You will get, I hope you will get the answer. I am leaving this question also to you only. Now let me take question number 2. Question number 2 is integration of square root of sin pi into cos raised to 5 pi d phi from 0 to pi by 2. From 0 to pi by 2. You see here, integral is in terms of pi. Integration pi is there, and d phi is there. Okay. Instead of x, they have given you d phi. Here, how will you integrate it? First of all, we know that differentiation of sin pi with respect to pi is cos pi. But cos pi, how many times it is given? Cos pi is given 5 times here. As cos pi is given 5 times, let me write it as this is integration of square root of sin pi. Cos raised to 5 pi is there now. You write it as cos raised to 4 pi, cos raised to 4 pi into cos pi d pi. From 0 to pi by 2, this will be as it is. This cos raised to 4 is there now. Cos raised to 4 pi, I will take in terms of sin pi. I want to take in terms of sin pi. If I write in terms of sin pi here and substituting t is equal to sin pi, we will get cos pi into d pi. That's all. Okay. It is 0 to pi by 2 square root of sin pi. This cos raised to 4 is there now, can be written as cos square pi whole square into cos pi into d pi. Then integrating from 0 to pi by 2 square root of sin pi. What is cos square in terms of sin? Cos square in terms of sin, we know the formula 1 minus sin square pi. Using the formula sin square theta plus cos square theta equal to 1, cos square theta equal to 1 minus sin square theta, I can write. Whole square, write it as it is. Cos pi into d pi. Now you substitute, that is substituting t is equal to sin pi. T is equal to sin pi and differentiating the function with respect to pi. We have to be careful. Differentiating the function with respect to pi. Dt by d pi is equal to differentiation of sin pi is cos pi. Okay. We have here dt is equal to cos pi into d pi. Dt is equal to cos pi into d pi. I am getting this. Then we have to change upper limit and lower limit also for the new variable. When pi is equal to 0, t is equal to sin 0, we have 0. Next, when pi is equal to pi by 2, 90 degree, then t is equal to sin 90 degree, that is 1. Okay. Now integral is integration of square root of sin pi means t, square root of t, which is multiplied with 1 minus of sin phi means t, 1 minus t square whole square, cos pi into d phi is dt. integrating from 0 to pi by, integrating from 0 to pi by 2 is for the variable pi. Now for the new variable t we need to write, it is 0 to 1. Next, how will you integrate? Very easy, it is done. Integrating from 0 to 1 root t, let me write it as t to the power of 1 by 2. And here you say it is in the form of a minus b whole square. A minus b whole square formula, you expand it, a square plus b square minus 2a. A square 1 square plus b square, t square whole square means it is t raised to 4 minus b square minus 2 into t square into dt. Next, integrating from 0 to 1, t raised to 1 by 2 will get multiplied with these terms, t raised to 1 by 2 plus t raised to 1 by 2 into t raised to 4 minus 2 into t raised to 1 by 2 into t square. Whole integral is with respect to t. Yes, integrating from 0 to 1, t raised to 1 by 2 plus of t raised to 1 by 2 plus 4, t raised to 1 by 2 into t raised to 4, it is t raised to 1 by 2 plus 4 minus 2 into this is t raised to 1 by 2 plus 2. Whole integral is with respect to t. Next, integrating from 0 to 1, t raised to 1 by 2 plus t raised to 1 by 2 plus 1. If you cross multiply, this become 1 plus 8 by 2 means it is 9 by 2 plus, minus is there, right, minus of 2 into t raised to 1 by 2 plus 1 is 1 by 4, 1 plus 4 by 2 means it is 5 by 2. Integrating with respect to t. Yes, can we integrate it now? Very easily we can integrate. T raised to 1 by 2 integration is t raised to 1 by 2 plus 1 by 1 by 2 plus 1 plus t raised to 9 by 2 integration is t raised to 9 by 2 plus 1 by 9 by 2 plus 1, because these are all in the form of x raised to n. Minus of, see, it is 2 into t raised to, yes, 2 is outside, into t raised to 5 by 2. 2 into this is t raised to 5 by 2 plus 1 by 5 by 2 plus 1 equal to, here it is 0 to 1. Now t raised to 1 by 2 plus 1 is 3 by 2 by 3 by 2 plus of t raised to 9 plus 2 by 2 11 by 2 by 11 by 2 minus 2 into t raised to 7 by 2 by 7 by 2 from 0 to 1. Let me simplify, let me write one more step. 2 by 3 into t raised to 3 by 2 plus 2 by 11 into t raised to 11 by 2. This 2 will come to the numerator minus 4 by 7 into t raised to 7 by 2, 0 to 1. Yes, now we will substitute the upper limits and the lower limit. Substituting the upper limit, t is equal to 1. This is 2 by 3 into 1 to the power of anything. 1 to the power of 3 by 2 is 1. So, it is 1 only, plus of 2 by 11 into 1 minus of 4 by 11 into 1 minus of 0, 0, 0. This is 0. Here, we will simplify. 11 2s are 22 plus 3 2s are 6 by 33 minus of 4 by 7. This is 22 plus 6 is 28. 28 by 33 minus 4 by 7. From numerator, here 4 is common, I can take outside. 4 into 4 sevens are, it is 7 by 33 minus of 1 by 7. Then 4 is outside, let it be as it is, into, if you cross multiply, 7 into 7, 49 minus 33 divided by 33 into 7. 49 minus 33, 7 plus 9, 7 plus 9, 16. 4 into 16 by 33 into 7. Is there any common factor? You can cancel. I think there is no common factor. 4 into 16 is 64 divided by 7 3s are 21. 7 3s are 21 plus 2 is 23. So 64 by 231 is the answer. This is about problem number 2 in the exercise 7.10. Problem number 3 onwards we will take it in the next class. Thank you.